Hi guys, welcome to another lesson of Algebra 2. This lesson is on page 71 of your packet. We are learning how to describe the transformation of a certain function. So we're going to compare the new function from the parent function. So we begin with functions of the form g of x equals x squared plus k. If the value of k is positive, then the parent function simply shifts up by k units. So if your k is a positive 2, then your function shifts 2 units up. If your k is negative, then the parent function shifts down by k units. So if your k is a negative 2, your function will shift down by 2 units. Now let us consider quadratic functions of the form g of x equals ax squared plus k. The sign of a reveals the direction that g opens. So the sign of A will tell us if our function is facing up or facing down, while the magnitude of A tells us if G is wider or skinnier than the parent function. So if A is greater than 1, then G grows faster than F, hence it's skinnier than the parent function. So if our A is positive 1, positive 2, positive 3, so as the A increases, the function gets skinnier. Or I think other term that you'll find in the book, they'll say as the A increases, the graph gets narrower. And then if our A is between 0 and 1, because it's an absolute value, so we don't have a negative, right? So if it's between 0 and 1, so like say, for example, 1/4 or 1/2, then G grows slower than F. And then we say that the function is getting wider. So as it gets smaller than, right? So it gets closer to 0, it gets wider. All right, now let's consider the quadratic function in the form g of x equals x minus h squared. If the value of h is positive, then the parent function f moves to the right h units. So if my h is a positive 4, my function moves to the right 4 units. If my h is a negative 4, my function moves to the left by 4 units. We now combine this and consider quadratic functions written in the form g of x equals a times x minus h squared plus k. And I want you to remember the position of where we find k, where we find h, and where we find the a value. In this case, the value of h reveals how much the parent function moves to horizontal direction, to the right or to the left. And the k value reveals how far our function moves in the vertical direction, so up or down. In particular, the vertex of f moves to the point h and k. So technically, whatever your h and your k value is, that is the points of your vertex, right? Or the coordinates of your vertex. Saying we refer to this form of a quadratic function, the vertex form, or as the completed square form. Now, we now have three distinct forms that we always see. First, we have the standard form, which we are familiar with because we already did factoring. We have the factored form when we were trying to graph. We see that all the time. And then we have here now that we're trying to introduce is the vertex form, which you have the a value, h value, and k value. Okay. In here, you have all the possible ways of how to describe the transformation. And I'm going over it one by one. And every time you describe a function, you can always come back to this example, to this note, and compare or try to see what or how you will describe the transformation given to you. So let's start with the sign of A. There are only two possible signs of A. It's either a positive one or a negative one, right? But if A is less than 0, what does that mean? A is less than 0, meaning if A is negative. Okay, so if you have a negative A, all you have to say is that the graph is reflected across the x-axis. What does that mean? Reflected across the x-axis, meaning your graph is facing down. So whenever you have a negative A, you know that the graph is facing down. Now, let's move on to the next one. If A is greater than 0, meaning if A is positive, you would say that there is no reflection across the x-axis. In other words, the graph is facing up. Now let's move on to the absolute value of A. So when we say the value of A, the absolute value of that, so it's always going to be a positive. So I do not care at this point if the A was a negative or if the A was a positive. I care about the value of A itself. So if A is greater than 1, I would say that I have a vertically stretched by a factor of A. If A is between 0 and 1, remember there is no negative, then I'd say vertically shrunk by a factor of A. If A is just equal to 1, not greater than 1, not lower than 1, just 1, then I would say no vertical stretch, meaning that the new function g is the same as, you know how skinny and how wide it is, they are the same size technically. So we would say no vertical stretch. If h is greater than 0, let's move on to h. If h is greater than 0 or if h is positive, I'll say that I have a horizontal shift to the right. If a is less than 0, if h is less than 0 or if h is negative, I have a horizontal shift to the left. And if h is 0, I have a no horizontal shift. Moving on, if k is greater than 0, if k is positive, your graph is going up. If k is less than 0 or if k is negative, your graph is going down by that certain unit. And then if k is just 0, then you have a no vertical shift. For the minimum and the maximum value, I think that would come easier for you because we did that one over and over, right? When we're trying to compare vertex. If my A is greater than 0, meaning my graph is facing up, I have a minimum value. Not bad, correct? I have a minimum value of whatever the K is. If my graph is facing down, I have a maximum value of whatever the K is. Because remember, H comma K is the vertex. And when we try to say maximum and minimum, we're looking only at the K value of it, all right? Or the Y of the vertex. And for the domain, easy. We always just say all real numbers. For the range, though, there are two ways to say it. If A is greater than 0. So if my A is greater than 0, that means my graph is facing up. It's greater than or equal to K. Of course, because you're just trying to say that all the Y values in this graph are from this point all the way up. If you have a facing down, your G of X would be less than or equal to K. That makes sense, right? Okay, moving on. Let's try an example. And I know it's a lot of information to like, should I memorize all of this? For now, you don't have to memorize all of this. You just need to familiarize, when to say stretch versus shrunk, when to say horizontal shift, vertical shift, and stuff. And let's try. We have here two functions. The broken line is the parent function, and then the red line is, or the red graph is the g of x, the new function. And we're trying to compare the transformation, or technically how it changes from f to g. And let's get the values. We have my a, h, and k. So my k is 3, my a is 2. Oh, how come my h is negative 1 inside and then my h here, it's I have a negative 1 inside and then I have a positive 1 for h. Remember, if it's in the factor form, you always make it equal to 0. So my x is equal to 1, and so my h is equal to 1. Does that make sense? Now let's try to describe the transformation. First, I need to describe the sign of A. The sign of A is a positive. Next, the value of A, my H and my K. So if my A is positive, I would say no reflection across the x-axis. If my A is negative, I would have said reflected across the x-axis. Okay? Now I'm going to the value of A. Because number 2 is a number greater than 1, I'd say vertically stretched by a factor of 2. If my A was lower than 1, so if I had a 1/2, I would have said vertically shrunk by a factor of 2. And if you notice, vertically stretched meaning it's skinnier. If you notice, the red is skinnier than the broken line graph. Okay, and then for H, you either say horizontal to the right, to the left, or no horizontal shift. But in this case, our H is a positive 1, so we're going to have a horizontal shift 1 to the right, a vertical shift 3 up. For the vertex, it's a combination of H and K value. And because my graph is facing up, I have a minimum value of whatever the k is. And my k is 3, so I have a minimum value of 3. My domain is always all real numbers. My range is because I said that hold on, because I said that my minimum value is 3, I'm saying that all my y, all the range of this graph is going to be from 3 and above. And that is the reason why I have g of x is greater than or equal to 3. Okay, let's jump to number 1 example. This is my k, that's my a. Oh, it looks like we don't have an h, correct? Remember, now we have g of x equals ax minus h squared plus k. So it looks like we have the k, we have the a, but we don't have this part, right? So our a is negative 1, our h is 0, our k is 3. And we know that our vertex is a combination of h and k, so I can just write that there now. Okay, now let's describe the sign of A. Because the sign of A is a negative, I would say that this is reflected across the x-axis. And because that is the sign of A. Now the value of A, remember, if the value of A is greater than 1, I say vertically stretched. If the value of A is lower than 1 or between 0 and 1, I will say shrunk. If it's a 1, I would say no vertical stretch. Okay? Now 0 meaning there is no horizontal shift. Oh, I say no horizontal shift. It's not going to the right, it's not going to the left, it will be at the origin. And then my k is 3, so I have a vertical shift 3 units up. Okay, and then let's move on. For because my A is a negative, I know this graph is facing down. So what is that? Is that a minimum value or a maximum value? So we have a max value of K, which is 3. And then we have all real numbers. We have for the range, we have g of x. Because I'm saying that the maximum number of this graph is positive 3, all the values of my y, or all the y values, or the range, is going to be less than or equal to that number. Okay, I hope that makes sense. Now let's move on to next example. We have, that's my H, that's my K, that's my A. So my A looks like it's a 1. My K is a negative 8. And remember, before you decide for your H value, you make that equal to 0. So my H is equal to positive 5. And then my vertex is H comma K. So I'm just going to put that right there so I don't forget. And then I have to identify, is this graph facing up or facing down? Because our A is positive, so our graph is facing up. Okay, so let's describe the sign of A. The sign of A is a positive 1. So we will say no reflection across the x-axis. The value of A is a 1, positive 1. So it's no, or it's same thing, yeah. No vertical stretch. And then my H is 5, so I will have horizontal shift 5 units right. And then negative 8, so I have vertical shift 8, oh, I don't have space, 8 units down. Okay? Now, because I said that my graph is facing up, oh, how do I know that again? My A is a positive. And whenever our A is positive, we know our graph is facing up. And so because A is positive, we have a minimum value of K. What is our K? Negative 8. So we have a minimum value of negative 8. Now, because we have a minimum value of negative 8, let's put our domain first. Our range would be g of x. G of x, is it less than or equal to the k value, or is it greater than or equal to the k value? We said that in this function, our minimum value is negative 8. So if we're saying that if our minimum value is negative 8, that's the lowest point of the graph is negative 8, all the y, then all the range is going to be above or equal to negative 8. Okay? All right, do we need more examples? Okay, let's have more examples. We have g of x, we have a, h, and k. So negative 3, positive 2. Remember now, for h, we have x plus 8 equals 0. So x equals negative 8. So positive, because our A is positive, graph is facing up. What do we say again when A is positive? We say no reflection across the x-axis. If that was a negative A, I would have said reflected across the x-axis. Moving on to the value of A. Because the value is a number greater than 1, the value of A is greater than 1, I have a vertically stretched by a factor of 2. Oh, okay. And then this is for negative 8. I have, where are we going? Horizontal shift 8. Oh, I should say 8 units left. And then lastly, we have a vertical shift 3 units down. Okay? And we have, because h comma k is the vertex, our vertex is negative 8 comma negative 3. Moving on with, because I know that my graph is facing up because I have a positive a, I have another minimum value. Minimum value of k. So I have a minimum value of negative 3. And then this is always, 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 always all real numbers. And because my range, because I said that the lowest point of the graph is a negative 3, everything else should be greater than or equal to that number. Okay? You can stop here right now and you can do page 77 of your worksheet. But if you need more example, I could go over maybe one more example for you. Okay, so this is now an optional for you to watch. You can always just stop here and do your homework on your own. So let's have A, H, and K. Negative 16, negative 5, because x plus 5 equals 0 is a negative 5, negative 1 half. So my vertex is h comma k, so negative 5 comma negative 16. And because my graph, my a is a negative number, I know that my graph is facing down. So the sign of a is a negative. So I would say reflected across the x-axis. Moving on with 1 half. Remember now, I do not care about if it's a negative or if it's a positive. I care about the value of it, the absolute value of it. So 1 half. You only have 3 choices. Is it either greater than 1? That's a vertical stretch. If it's a 1, no vertical stretch. Because it's a 1 half, it's a number between 0 and 1. I would say vertically shrunk by a factor of 1 half. And then what is this? Negative 5. So that's a horizontal shift 5 units left, right? Because it's a negative number. And then negative 16, so vertical shift 16 units down. And because I have downwards, I have a maximum value of k. So I have max of negative 16, right? And then I have same thing. And because I'm saying that all the numbers, because I'm saying that the maximum value of my graph is negative 16, that tells me that all the y values of this function are all, what do you think? Oh, are all less than or equal to negative 16. Okay, I hope that this video made it easier for you to describe the transformation of the function. And please do your homework on page 77. And I will see you on the next video. Thank you for listening. And I hope that it did help you complete your homework. Thank you guys. I will see you on the next video.